Hello everyone. In this video, we will go over the core concepts of DynamoDB. Once you complete this video, you should develop enough foundational knowledge to be able to start using DynamoDB in actual real-world applications. So like always, we will start by defining the specific technology we are talking about, which is DynamoDB in this case. DynamoDB is AWS's managed NoSQL database service, and it provides fast and predictable performance with seamless scalability. DynamoDB is composed of three main things. One is tables. Tables themselves are composed of items, and items themselves are composed of attributes. A table is a similar concept as in other database systems, which is that it's a collection of data. A table has one or more items. If you compare it with traditional database systems, you can think of items as rows in tables. And then an item itself is composed of one or more attributes. So here on the right, you see a table which is representing people, and here are the items within that table. And then these are the attributes for the items of the table. Few things to note here is that each item has a primary key, which is person ID in this case. And other than the primary key, the table is actually schemaless. DynamoDB is not going to enforce any schema requirements on the items on any of its tables. The only thing which it's going to enforce is that the primary key attributes. It could be one or it could be two attributes in case of composite primary keys. Also, you can see the values are scalar. So this is scalar, but then you are also seeing complex values. For example, in case of address, this is a complex value. So DynamoDB supports both. This is another example of another table which is representing music. One different thing to note here is that it has two primary key attributes, the artist and the song title. So in all entries, you're gonna see that these two attributes would always be available. Other than that, once again, it's schemaless. So you're seeing year is item number 2, but it's not there in item number 1 and not there in item number 3 as well. And then you're also seeing promotion info, which is a complex type, and within promotion info it has nested attributes, so a complex type within a complex type. DynamoDB supports nested attributes up to 32 levels deep, which is quite a lot and serves most use cases, and hopefully you don't need to go to this level of depth in terms of nested attributes. Let's look into how DynamoDB stores the data. This is a very important concept to master because this is going to form the basis of our database design, our querying, our partition key and primary key selection. So it's very important to know it's not just an internal implementation details. From an application development perspective, this information is important. That's why it's mentioned in this presentation. So DynamoDB uses partitions to divide and store data internally. We'll take our people table as an example, and here is one possible implementation of how DynamoDB could store data in the people table internally. Here we are assuming that DynamoDB might have partitioned the table into 3 partitions, and then the data is spread across these 3 partitions. Now, of course, DynamoDB being a distributed service, each partition might be on a separate host. So here, this is stored here in partition 1. 103 is stored here in partition number 3. And then there are some other entries stored in partition number 2. DynamoDB uses the primary key to get to the partition and the item You will see more of this in the upcoming slides. Also, I want to mention the two retrieval operations supported by DynamoDB. Number one is query operation, which is the faster, efficient operation which uses the primary key. Once again, more on this in the upcoming slides. I just want to mention that query is the fast and efficient approach to retrieve data. So it uses the primary key to directly get to the data. It doesn't have to do any scans of the table. The other operation is scan operation, where it is going to perform a full table scan to get to the data that is being searched. Obviously, this is slow and costly, but it's flexible because it doesn't require us to specify the primary key attributes, whereas for the query operation, we are required to specify the primary key attributes. Let's talk about the primary key now. Primary key is a required component in DynamoDB, and it uniquely identifies an item in the table. There could be two kinds of primary keys. One is the partition key only primary key. It is composed of a single attribute. You saw person ID in the first example of the people table. And it tells DynamoDB in which partition the data is residing, as well as the exact location of the data within the partition. The other kind of primary key is called the composite key. It is based on the partition key as well as an additional sort key attribute. The partition key is used to determine the partition and also the location within the partition where the data would reside. But since in the composite key scenario, there could be multiple entries, multiple items having the same partition key, DynamoDB is going to use the sort key to keep all the data with the same partition key sorted within the location. And that is where the sort key comes into play. We'll see this in more depth very soon, actually now. So here we are talking about the single primary key scenario where the primary key is based on the partition key only. The people table was an example of this scenario. So if we look further here, what we are representing is, so this the people table is partitioned, and the partition key is leading us to the entry within the people table. It's telling us the partition where this record is located, as well as the location within the partition where this record exists. Here is another example of another person entry with person ID 103, and it is located in partition number 3. So as I was mentioning, it tells Dynamo, the partition key tells Dynamo the partition as well as the exact location within the partition. And in a single primary key scenario, one partition key always points to a single record. In the composite primary key scenario, we go to our music table, and here you'll see that the partition key is taking us to the partition as well as the location within the partition where all the records having this partition key are stored. Further, the records in this location would be sorted using the sort key. So as with the single primary key scenario, the partition key is telling us the partition and the location where all the records for this partition key are stored. But the sort key is further going to point us to the exact location where the data exists. So in this case, from the sort key, we know that this data is pointing to this entry. And here we are depicting, because you have another item with the same partition key but different sort key. So it's taking us to the same location as far as the partition key is concerned, but then further the sort key is telling us the exact item it's pointing to. And here is another example of another partition key and sort key. So in composite primary key scenario, multiple items, as I mentioned, could have the same partition key. Okay. But as I mentioned before as well, the whole primary key, which is the partition plus the sort key, would always point to a single element. So here are the examples of that, which we already saw. Now, let's further go into the implementation details of DynamoDB and see how does it get to the item from a given partition key. How is it going to get to the actual item? How would it know the partition number as well as the location within the partition? First, we're going to talk about the single partition key scenario, and then we're also going to talk about the composite primary key situation. So the core concept is that of the hash function. I had hit this detailed up till now just to make things simple, but now we're going to talk about it because it's an important concept to understand. So a partition key value is passed to a hash function, and then the hash function's output is used to determine the partition as well as the location within the partition. So taking the example of the person ID from the people table. So let's suppose we queried using the partition key, which is person ID. And how do we get to the location? How do we get here? So the partition key value would be inputted to a hash function, and then the hash function's output would be used. Here I'm just creating an abstraction that there is some partition index logic that takes the hash output and then converts it into a partition number. In reality, this is most probably going to be a mod function, which restricts the output to the number of partitions. So here, whatever that logic is, gives us the partition number from the hash output. This is how we're getting to the partition. Now, how do we get to the location within the partition? The same hash function output can be used as an index to index within the partition. So once again, I'm abstracting that logic into this, but most probably they've used the modulus function here as well to provide us with an index within the partition. And that's how we are getting to the actual item within the partition. So this was the case of the single partition key based primary key. Now we're going to talk about the composite primary key, which is not going to be too different from the single partition key scenario. So here we are taking the music table as an example, and actually I have the whole records, but we just want to focus on these two actually, right? So how do we get from here to here, right? This item should be pointing to this one. So same as in the single partition key based scenario, the partition key, which is artist in this case, is fed into a hash function. The hash function's output is used to deduce the partition number. And then once again, the output of the hash function would be used as part of our item index logic. But at the same time, in this case, we would also be using the sort key value as part of our item index logic to determine the exact location of the item. So that is the additional thing to consider in case of the composite primary key. Couple of side notes here. The partition key is also called a hash attribute. And obviously that is because of its role in the generation of the hash, which is used to get to the partitions. Also, it's very important to note that the hash function is supposed to evenly distribute data across all the partitions. And for that, we need to help Dynamo with this, because we need to select a partition key that is going to generate distinct values rather than a partition key that is just going to generate few possible values. So for example, a Boolean would be a very bad partition key, whereas a UUID would be a very good partition key. Also, sort key is also called the range attribute, and that is because it can be used with range queries. So as we all know now that Dynamo stores all the items with the same partition key in sorted order in the same location. And due to this fact, it's already sorted. So we can use the sort key for sorting. We can also use the sort key for searching. For example, equal to, contains, these kind of queries. And then we can also use it for range queries like between, greater than, less than, and begins with. So far what we have covered about DynamoDB, it seems that we have a major constraint here, and that is that a table can only have one primary key, which means that only if we are using that primary key in our queries, the retrieval operation would be efficient. But if we want to use any other field, then we would have to do a full table scan, which obviously is very inefficient and costly. So in the two tables that we have seen so far, the person ID in the people table and the artist in the music table, these are the only attributes that can be used to efficiently query data. Anything else, we have to do a full table scan, which is inefficient. Now, for most real world scenarios, if this is a constraint that we have to deal with, then we pretty much cannot use DynamoDB in a lot of real world scenarios, because our access patterns in applications, it's highly likely that we are going to have additional access patterns. So for example, in the case of the people table, what if we also want to query based on the first name attribute? So the solution to this, which DynamoDB provides, are secondary indexes. One is called the global secondary index. The other is called the local secondary index. Now we'll see in the next two slides, and we'll see in the next two slides what each of these indexes are. With the global secondary index, your partition and sort key can be totally different from what you have on the table. So in the case of the people table, we know the people table only had a single partition key as primary key. So the person ID is the primary key on the table, and that is being used to partition the table as well as get to the partitions and the item when we are querying. And as we said in the previous slide, what if we want to efficiently query based on first name as well? So we are going to create a global secondary index on first name attribute, and we would be able to use the same efficient query operation to directly get to the items using the first name. Now, the reason why we are depicting two separate illustrations is because of the fact that a global secondary index is going to store partitions separately. In addition to the partitions for the table, global secondary index is going to store its partitions separately. So there are cost implications to this. It provides a lot of flexibility, but there are cost implications to this as well. The other kind of index is local secondary index. This index has the same partition key as that of the table, but the sort key can be different. So this is the original music table with its partition and sort key based primary key. And here we can create a local secondary index, which is going to use the same partition key, but can use a different sort key. So this is giving you the flexibility of using additional attributes as sort key attributes. Also note that unlike global secondary indexes, for local indexes, we don't have a separate partition key. So there is no need for Dynamo to maintain separate set of partitions for these indexes. We covered quite a bit here in this short presentation, so I'm just gonna sum it up now. So we now know DynamoDB is AWS's NoSQL managed database service, and it is composed of tables, items, and attributes. It has a primary key, which allows for fast retrieval of data. The primary key is composed of a partition key attribute and an optional sort key attribute. Dynamo supports two main retrieval operations. One is query, which uses the primary key, and it's obviously fast and efficient, and it provides predictable performance. And then the other operation is scan, which performs a full table scan. It is slow and costly, but it is flexible as well because you can query based on any attribute. DynamoDB, being a NoSQL database, is schemaless. The only attributes for which some sort of schema is enforced are the primary key attributes. And we also have secondary indexes in DynamoDB. We have the global secondary index, where we could have the primary key and the sort key that could be totally different from what we have on the table. We also have local secondary indexes that use the same primary key but can have a different sort key than what we have on the table. So this is the end of this presentation. I hope you liked it, and I hope this helped your understanding of DynamoDB. Stay tuned for more presentations and videos on DynamoDB. If you haven't already, please subscribe to the channel, and I'll see you in the next video. Thank you.